that was a quick intro to who you are as students and why you might be interested in software development. But what is software development? Let's talk about some high-level concepts before we understand where this class fits into the overall scheme of things. So when we're dealing with software, I'd like to introduce this concept of an information system to you. An information system is a set of information inputs and outputs, or let me put it to you a different way. In my definition of an information system, there's three components or three legs of this definition. One, the system processes or takes in or captures information inputs. And in this kind of data flow diagram, you see those denoted by arrows flowing into the system. In this data flow diagram, the system is at the center with this weird shape. One, the system should process information inputs. Two, it should output some information outputs. And three, it has to be for some purpose, like to help some humans, to be valuable in some way. So here's an example diagram of a system that I built for some clients a few years ago. It's called Tonebase. And I'd love for someone to try to interpret this diagram to try to understand what this system is about. Does it remind you of other systems that you may have seen or worked with? What is the purpose of this system? Revenue flowing around. And so, yeah, this is a system that facilitates professional artists recording like how to play the guitar kind of videos, and then users who want to learn how to play the guitar will watch those videos and pay for this knowledge. So just by using a data flow diagram, we can kind of see the overall high-level scope and responsibilities of any system. Also, with these information inflows and outflows, here we're talking about information. So it's not like an assembly line where we might have like a physical input into some new product that's going to be built. These information inputs and outputs are information. So for example, if you are grabbing a deli sandwich from the local corner grocery, if they don't have a super technologically inclined system, the information input that you would give there if you're ordering a sandwich is like your order. Hey, I want a tuna sandwich. That information goes into some kind of system, whether it be technology-based or not. And then the information output from such a system would not be your sandwich because that's a physical good, but rather the receipt that has the total on it. That's one way of conveying it, an information output from your sandwich ordering system, for example. Anyway, so information systems, that's what we're kind of dealing with at a high level. Generally, the information system's goal is to create value in the data that it processes. So the system might try to change data to information or try to synthesize information into human-related knowledge. So examples of data are like just some text and some numbers, maybe some sales figures like we sold $100, we sold $200, we sold $300. Those are just numbers, maybe not making much sense until we put them into a larger context. Maybe if we synthesize or organize that information, for example, into like a chart of sales over time. At this date, we had $100 in sales. At this date, we had $200 in sales. At this date, we had $300 in sales. If we chart that over time, now this information has been synthesized. And so maybe it'll help us make decisions. Oh, sales are going up. Oh, sales are going down. So we're starting to synthesize and collect and mesh up this information. Maybe we're layering on other data coming from some other system. Finally, we might be able to use an information system to produce human-like expertise and human-like knowledge. So we can kind of characterize different systems at these different levels. And a basic system that just handles data, we can call it like a transaction processing system. As systems start to support our decision making, that might be a management information system or a decision support system. And finally, we have some expert systems that might emulate human actions and human decisions. So I'd like a volunteer to think about expert systems in particular. These systems that may be doing the job of a human, or in the past, a human would have to be doing that job, but now maybe a system might be able to do that job. Can anyone think of such an expert system or a few of them? So yeah, we've been talking about some systems so far, and they're all great examples of systems, mostly expert systems, some decision support systems, some transaction processing systems. I just like to put a point on this in terms of expert systems. I would say like Netflix recommendation algorithm would be like a good example of an expert system. I don't know if you young kids remember back in the day, like we might have to like go actually physically go to Blockbuster, like the physical store. I don't know if those exist anymore. And then you would go and ask the video clerk, hey, have you seen any good movies lately? And they might be like, well, what other movies do you like? And then they might recommend a movie to you manually based on your preference and interest. But right now we have Netflix, which does this automatically. And so based on other movies you've watched and other movies that similar folks with similar interests have watched, now that system is providing the recommendation to you, doing the job of that a human used to do. So Netflix recommendation system, another good example of an expert system. Finally, what about self-driving cars? This is so exciting. Right now, we still kind of have to drive our own cars for the most part, but this is an emerging technology leveraging artificial intelligence, and Tesla and other car makers are making self-driving cars, which could take the place of a chauffeur, for example. And I think that's super exciting. And so software is at the heart of a lot of these systems. But let's talk about different components that comprise any one of these systems that we just mentioned. I'd like for you to think about systems like this. They're comprised of these components: people, processes, hardware, software, networks, and a data store. People are the people who use the system or get value from it. Remember, I said in my definition of an information system, it has to be for some practical purpose. It has to be providing value to some people. And so we want to definitely consider the users and their experience as paramount and in the forefront of our thinking when we're building systems. Processes are the procedures that a system might facilitate. For example, in my apartment building, we have a small gym, and during COVID, the apartment building implemented a gym sign-up sheet in the lobby, and that was a paper-based process where if you wanted to sign up for a gym time, you would just kind of write that down. And so there's a process about that gym reservation action. But I ended up digitizing this process and creating an online app, and now all the residents of my apartment building use my app to reserve gym time. And so the process it has the same goals, but it's facilitated differently through technology in this case. And maybe I'll demo that gym reservation system for you. But anyway, processes, we can in many cases automate a process and reduce manual error by creating a technological system to facilitate that process. The next components are hardware and software. Without the other, each is kind of dumb. So what I mean by this is the following. Consider your mobile phone, but consider if it was like broken or if you didn't have any operating system installed on it. If you didn't have an operating system on your phone, you couldn't even turn it on. It's just a dumb brick. Maybe you could use it as a paperweight max or throw it at someone. I don't know. But with our operating system software, that's what helps us actually use this as a device. Conversely, if we have an operating system and a bunch of logic and code, but no device to run it on, that code is just theoretical. So it's by combining the software and the hardware, that's where the magic happens. And one without the other is useless. Other examples of hardware are like sensors. So on those self-driving cars, there might be some motion sensors or other kind of devices that are taking inputs into the process. The final two components, first is a network, and this is how a system might transmit its data, especially sharing data with other systems and other stakeholders. Generally, the network that we use most often to transmit data between systems and within a system is the internet. And you've all used the internet, and later in this semester, we will learn how to programmatically fetch data from different places on the internet, including the Spotify platform, for example, that I'll be demonstrating to you by the end of class. Finally, if a system needs to access data later, like in a few days or in a few minutes or in a few years, we need to store that data somewhere. Kind of like if you go to the doctor's office, they're storing a file about you, or they used to, in like a physical file in their like file cabinet. And so that file cabinet could be a data store. It's where we store the information for later. In a technological system, we might use a data store like Google Sheets or a spreadsheet, or if anyone's familiar with SQL, a relational database is very common, but databases are outside the scope of this course. So at most, we're going to deal with CSV files as our rudimentary data file storage. And we'll get to that after spring break. So these are the components of an information system, but it's the software that we're going to focus on primarily as we write code in Python to perform some kind of logic. When we create software, there's two general categories. One is operating system software, so like iOS and Android and Mac and Windows. And operating system software is like lower level. You could think of it as it helps the computer do its job, and we might not even care that much about how it's happening. Conversely, we also have application software, which helps a human do some kind of thing that they need to do. It's higher level. So if you watch Netflix or use Facebook or go on Amazon, these are all examples of application software that are built on top of an OS. You can access them on top of an OS, and they'll help you do some things you want to do, whether it's Google Docs or even Netflix or anything you would download from the App Store. Is application software. All right, so we can build software, and in this semester, we're primarily going to focus on application software. We'll just take it for granted that we have an operating system to work with. We could write software in a number of different languages. So why Python specifically? Some of the benefits of programming in general, and certainly of Python, are in automation. So if there's a task that you would do once per week, for example, and it takes you like an hour, if we're able to automate that process, now maybe it might take you an hour or two upfront to write some code to facilitate that process, but then in the future, you can just press a button, run some code, and it's done like in a flash. And so as a long-term process, now it helps save you time. You don't have to sit there for an hour doing the same thing that you did last week. You can kick off your program and go for a walk or hang out with friends or do whatever you want to do. So automation helps us as some kind of worker to save us time, but also reduces manual errors that could be introduced into the process by some manual version of the process. So programming, we have benefits of automation. Also, benefits of scale. I don't think this applies too much to you folks, but if you ever worked with a very large data set, then it may become hard and slow. If you're using other tools like spreadsheet software, maybe you can't even preview or open a file because it's too large. But in programming and in Python specifically, we can process big data with no problem. So for my machine learning research, I process tens of millions of data points from the Twitter API, from the Twitter service about certain political conversations. And that's what I do for my research. And I can totally store that data and process it using Python. Python specifically also has a good community behind it. So there will be times when we are not sure of how to do something that we need to do, and we'll have to go look it up online. It's a very common process. The nice thing is that if you're programming in a language that has a good community, there should be some good support for you online, whether it is official documentation for certain functions or parts of the language that we're working with, or presence of third-party libraries called packages that we may install and use that other people in the community have built for us to help us out, or presence of blog posts or Stack Overflow posts. If anyone has heard of Stack Overflow, it will be a good resource for you as you try to answer some coding questions. So we have a good community in Python. Finally, why would we choose Python? Or not finally, but next reason why we choose Python is because it's a very popular language. Here we see it's among the top 2 most popular languages. So you can expect there to be lots of jobs using Python and lots of people using it. Certain programming languages can be used best for certain purposes. So really also when we're choosing a programming language, it's about choosing the best tool for a job. In this case, the top language, JavaScript, is only used for front-end development, like front-end applications that we could use in the browser. And so it's limited. But rather Python is a back-end language and it's very versatile. We could use software development, data science, machine learning, and lots of stuff. So we see Python is very popular and wanted and loved, but really we're just choosing the right tools for the job. And Python can be used versatilely for many purposes. So these are all reasons why we would choose Python. And many of you in your onboarding survey said that you're excited to learn Python specifically, so that's great.